Okay, in this little clip, we're going to extend the concept that we learned in the last slide to what happens when there is a value in the numerator other than one of our rational exponents. So we have a little setup over here. We have 27 to the 2/3. We know using our property of exponents that we can represent this value doing 27 to the 1/3 squared. So kind of reverse of what we did on the last key concept. Now we also just learned that 27 to the 1/3 power, that 1/3 means it's a cube root. Now when I'm doing these type of problems, I always like to make the numbers simpler. So I can either cube root 27 or I can square 27. It's way easier for me to mentally cube root 27. So the cube root of 27 is 3. It takes 3 3s when you multiply to get 27. And then square the number. So 3 squared is actually 9. So you can kind of see what happened there. The bottom number becomes the root, but that top number becomes the power. So this is the power, and this is the root. I always kind of think of it as roots grow underground, and so like the 3 is on the bottom of the fraction, so it's kind of underground. And then the power I always think is on top because like a higher power, so it's higher. Now, if I want to apply that one, let's take a look at our example over here. We have 64 to the 2/3. That's written as a rational exponent, and they want us to rewrite it using radicals. So again, the bottom number is the power, and the top number, or I'm sorry, the bottom number is the root, and the top number is the power. So that's the same as writing the cube root of 64 squared. If I want to determine the value of that, the cube root of 64 is 4, and 4 squared is 16. So it doesn't matter what order you do your operations in on these, but it is always going to be easier to do the root and then the power because you're going to make the number